Hey everybody, I want to do a review of web work number 9, question 2, which is just practicing getting our differential equations, the form of yp. The table in our notes is actually going to be really helpful for this. I think it gives us a pretty good general description of what the form looks like. But like Professor said in his lectures, that it really just takes some practice to get used to what they're all going to look like. The one thing that I had to go back and look at was sometimes the form of yp has more terms in it than g of x, so that tripped me up on a couple of these problems, so let's go over some of them. So for the first one, we have y double prime minus 8y prime plus 15y equals 7t plus 9e to 3t. And then we have our yc here. So the first thing we're going to look at is our g of x, which is right here. So with this term, it's going to be at plus b, which is our extra term there, plus c e to the 3t. But when we look at this, we already have a constant times e to the 3t in our y of c, so we need to change this so we have a new term there. So we're just going to multiply that one term by t. So our y of p is going to end up as at plus b plus ct of e raised to the 3t power. So it's not necessary either on this one. I got tripped up. I thought we were supposed to multiply the whole entire expression by t, but it's only the piece of the expression that we need to change. So if we look at the next one, our new g of t is going to be 7t squared minus 6t plus 4 plus 4 times e raised to the negative 3t. And so with our y of c listed for us, it's awesome. They did the hard stuff, I think, for us right here. So we're going to get originally at squared minus, or plus bt plus c plus d e to the negative 3t. But with this one, since we have this just constant here, this c, we need to change that. So this whole piece is going to be multiplied by t. So we finally, y of p is going to be equal to at to the third plus bt squared plus ct plus d e to the negative 3t. And because this is raised to the negative 3t, we don't have to change it because this is positive 3. So they're different enough. So if we look down at c, our g of t is 9t squared minus 6e to the 3t, and then we have the same yc below. So we're going to get at squared plus bt plus c plus d e to the 3t. And so with this one, since this e is raised to 3t, we will have to multiply this whole thing by t, since we still have that constant term there. So this one, yp equals at cubed plus bt squared plus ct plus dte to the 3t. So it's not so bad as long as you're paying attention to what terms are already in our answer, y of c. Those ones I think are pretty good. If we look at the next one, we finally are going to have our have some trig in here. So our g of t is 7 cosine of negative 6t, and then here's our y of c here. So the form on this one, if we just have one trig term, it's going to end up with 2. So we have a cosine of negative 6t, and we always keep what's in the parentheses. That always stays the same in these. And it's going to be plus b sine negative 6t. And the cool thing about these ones is even if this was 7 sine here, it would still have this form, except sine would be first and cosine would be second. Order doesn't really matter on that one, so it would still just be the same answer. And with this one, this is actually our final answer, because in our y of c, both terms have an e to the 3 raised to the 3t in them, so that one's good to go. Okay, so if we take a look at part E of this problem, our g of t is 7e to the 3t sine of negative 6t plus 9e to 3t. So there's two parts that we need to get the form of. So for the first one, it's going to be a e to the 3t sine to the negative 6t plus b e to the 3t times cosine to the negative 6t. And then for the last part, it's just going to be plus c e to the 3t. And since both of these terms are already in our y of c, we need to multiply those by t. And we're going to end up with our y of p equals a t e to the 3t sine negative 6t plus b t e to the 3t cosine negative 6t plus c e to the 3t. And that's what you get for your final answer. I don't think that these problems are too bad, but it just takes practice. I know I had a little trouble when I first looked at these, but I'm feeling a lot more confident with it now. I hope this helps. Good luck on exam 2. Hope everybody's doing well. Have a good weekend.